Alright, so here are my PDE textbooks. This is the #1 introductory textbook that I would recommend to anyone who hasn't studied PDE before. You're just looking, you're starting out in the subject, maybe you're taking a first year class on it. Read this textbook, okay? Funny story, when I was taking PDE, it was over the summer, okay? It was the first time that I'd taken a course in PDE, and not PDEs, PDE, because it's PDE. See that? So anyways, I was taking a course over the summer. The teacher did not know PDE. It turns out that they had a scheduling error, and in fact, the teacher that they assigned didn't know PDE. It was like a big kind of mistake in the department, and so basically we learned nothing in that class except I would sit in the back for 2 hours, 3 days a week, and guess what? I learned a ton because I would just sit in the back of the class and just read this textbook. And this is one of the first textbooks that I really read, and that class taught me the importance of reading the textbook. Reading the textbook is everything, guys and girls and people. Reading the textbook is everything, okay? That's how you learn math. So let's delve into the table of contents here. I'm just going to quickly show you what this textbook covers, because I hope that if you're just getting started in your education and you're learning PDE, I really hope you cover this textbook, okay? It talks about the heat equation, talks about as just kind of a model for getting started, method of separation of variables. This is of course important for engineering, and there's a lot of cases where the method of separation of variables is quite useful. This is a more general, this is kind of a very specific case of what's called spectral theory. Okay, then we have Fourier series, wave equation, Sturm-Liouville eigenvalue problem, and then we start getting into some numerical methods, finite difference numerical methods. That's really important to know. It's really important to be able to implement on a computer, and this is something that I need to go back and review, to be honest. I'm currently studying numerical methods as well for my research. And then we have 7 higher dimensional partial differential equations. So I think my course, I read all the way through chapter 5, and then I read this chapter 7 here. And unfortunately, I skipped chapter 6 back in the day, which I do not recommend skipping. Okay, then we have chapter 7, higher dimensional PDE, and we'll get to, and then chapter 7 is kind of the beginning point for a more advanced course in PDE. So more advanced course in PDE, you're going to be doing higher dimensional partial differential equations, okay? All right, now we have some non-homogeneous problems, green functions. Green functions are critical. If you find the Green's function, you can solve everything with a linear PDE at least. So this is critical. Green's functions play a crucial role in quantum field theory, and the reason for that is because the problem which we know how to solve, basically the harmonic oscillator Lagrangian, the solution is using Green's kernel. And everything else is just perturbation theory from there, essentially. That's more of a joke, but no, it's seriously super important to all of physics, all of this stuff. Everything in this textbook is going to get used in your physics classes, in your engineering classes, anywhere you go. If you want to do applied math, this textbook is the best introduction. I would recommend it above all else for an introductory level, okay? Now here's another possible introductory level textbook. This was offered at the advanced undergraduate level PDE's class. Now, PDE class. So I would not recommend this book. No offense to Logan. I think that it's good in its own way, but it's a little bit too advanced for an introduction, but it's not rigorous enough for advanced treatment. So it's kind of this weird hybrid where it's like trying to get more advanced, but then it's not advanced enough, not rigorous enough, but trying to also be rigorous at the same time. Okay, so here's another introductory level textbook. This is also an undergraduate level textbook. This textbook, I referenced it. I can't say one way or the other. I know it has some good exercises. It has a solutions manual. This was the textbook that was recommended online. But honestly, for the undergraduate level, just you cannot fail with this textbook. This textbook right here will not fail you. Literally, just go here, okay? For the first introductory level. Now, for an advanced undergraduate level, I recommend this textbook by Salsa and Virzini, Partial Differential Equations in Action. There's a few typos in this textbook, but the exposition is amazing, and it's a great It's a great follow-up to this textbook by Haberman, okay? This is the textbook that got used in the MIT course, undergraduate course in PDE. That's how I found this textbook. It is really good. I love the exposition, chapter 1. It kind of motivates things through Brownian motion. So you kind of get an introduction to Brownian motion if you hadn't seen it before, which is deeply intricately related to the heat equation because of the scaling and variance of the heat equation and the way that the variance of the normal distribution scales, okay? So yeah, so we have the heat diffusion equation. You can see that it starts off with the heat equation, but it's going to motivate it through this Brownian motion construction, which is very common in more advanced levels. There's a deep connection between PDE and Brownian motion, or just stochastic motion in general, okay? And then yeah, so we have a chapter on the Laplace equation, chapter on scalar conservation laws, waves and vibrations. We have a whole one-dimensional wave equation, then we're getting into multi-dimensional wave equations. And then the beginning with elements of functional analysis. So this is going to have all the ingredients for a more advanced treatment of PDE, and it's really well written too. Like I haven't read this entire textbook, but I can just say from what I have read, I've read a few chapters, and the exposition is really great. Now, I didn't read this textbook as much because I focused on the next textbook we're going to read, and I need to go back and read this. I just haven't found the time. But I can thoroughly recommend it from what I have read. I've also just used it as a reference for if I didn't understand topics in this textbook, which we're about to talk about, I'd use this as a reference, and it's just really well written. So this would be a good kind of advanced undergraduate textbook to follow up Haberman, okay? Now we get to my ultimate recommendation. This is the ultimate recommendation. Partial Differential Equations, 2nd edition by Lawrence C. Evans. If you want to learn PDE, learn this textbook. This is the textbook we used for my graduate course in PDE. This is the go-to. I mean, this textbook is just so good. Like, it's just insane. It's insane how good this textbook is. I can't even explain to you how good this textbook is. It's one of the best textbooks I've ever read. And the reason is just because of the way that he solves problems, like just the problem solving that goes on in this textbook, and the way that these PDE are addressed are just, it's in a way that's just so motivational, so helpful to and conducive to learning. So it starts off with some representation formulas. We go through transport equation, Laplace equation, heat equation, wave equation, okay? And then problems. Chapter 2 alone is going to be several months or a month or two of a graduate level class, okay? And then chapter 3, nonlinear first order PDE. So here we get into some nonlinear PDE theory, okay? Some chapter 4. So I think we covered in my graduate level class, we covered chapter 1, chapter 2. Chapter 2 took us at least a month, and then we covered chapter 3, nonlinear PDE, and I think it's first order, right? Yeah, nonlinear first order PDE. Then we skipped chapter 4, and we covered chapter 5, so Sobolev space. So this is the beginnings of functional analysis, and then we covered some chapter 6. So this is getting into weak solutions, some functional analysis stuff. And then finally, look at this, calculus of variations, non-variational techniques. So I'm still going to be working through this textbook. I have a study plan, and my current study plan hinges on one of my goals is to go through all the exercises in this textbook. I would recommend it. You need a background in analysis a little bit. So I would recommend an introductory background in analysis and a strong background in calculus, multivariable calculus. The biggest two prerequisites for this textbook are real analysis and multivariable calculus. If you have those two down, you're pretty well equipped to tackle this textbook, but it is not easy. It is a monster textbook. It's really hard, but it's just the perfect, it is the ultimate, it's like the go-to reference, okay? This is what I would recommend. It sits on sits on my advisor's desk, okay? A lot of professionals are going to be referencing this textbook. This is a great textbook. It's probably the standard in terms of graduate level PDE textbook. And then finally, I have another awesome recommendation, which is this book by Braziz on functional analysis. And functional analysis is deeply tied towards the solution of partial differential equations, because you could think about your partial differential equation as some operator, some nonlinear operator on a function space. And so functional analysis plays a big role in PDE in terms of proving existence and uniqueness results for solutions. Okay, and obviously even spectral theory, right, is going to play a huge role in PDE if you just look at separation of variables alone. So this textbook, I would pair it with the treatment of Lawrence C. Evans. Okay, so this is kind of a more functional analysis flavor of PDE, but this is a really good textbook. I've read a couple chapters from this textbook, and it's like really well written. I mean, just the exposition is just wonderful here. Let's go through the table of contents here. Yeah, so you start, this is like the introductory functional analysis topics. Okay, so you start with some functional analysis, uniform boundedness principle, and closed graph theorem. These are critical concepts in functional analysis. Again, weak topology. Again, this is going to be functional analysis. So you definitely need a real analysis background to cover this. Okay, so you need a background in real analysis. See my video on real analysis textbooks before you cover this textbook. But once you understand real analysis, you can go here, and then we have LP spaces. Of course, you're going to cover that in real analysis, Hilbert spaces, and then you finally get to compact operators, spectral decomposition of self-adjoint compact operators. So a lot of times you want to represent PDE as a compact operator to prove existence of solutions. Okay, you can view them solutions as some stationary point of the PDE operator, and then. Yeah, we have some Sobolev spaces, boundary value problems, elliptic boundary value problems, and then evolution problems. And it ends, this is kind of funny, it ends with the heat equation, the wave equation, okay? That's hilarious because almost all other textbooks start with the heat equation and the wave equation, okay? This textbook ends with the heat equation and the wave equation. I really like that, okay? I really, really like that. And as y'all can see, I use I use some of my older Pokemon cards as bookmarks for the textbook. So, but anyways, yeah, these two are the ultimate recommendation. These are what you want to end up reading. And then the path to get there, I would recommend first Haberman, and then for those who are more ambitious, or maybe you've already covered Haberman. Honestly, even if you're ambitious, cover Haberman. It's literally super good. Then talk to Salsa Verzini and look at PDEs in action, okay? Once you cover PDEs in action, hopefully you get to the point where you start calling PDEs PDE instead of PDEs. And then once you start calling PDEs PDE, you can tackle this book by Lawrence C. Evans. I'm just kidding. But no, this is going to be a difficult textbook, but this would be the third stage. So once you cover this textbook, or read a few chapters of this textbook, read some of this textbook, check it out. There are a little bit of typos, though. I will say you need to be a little bit careful. There are some minor typos in this textbook. Then you move on to Evans and Brazis, and these should be the ultimate end goals. Is ultimately Evans is the pinnacle textbook. I'd recommend it above all else. But then also this is an excellent pairing. It's a nice pairing of two different flavors of how to attack PDE, okay? Two different flavors. You have a functional analysis perspective, which is really useful in research. This is a really common approach. Then you also have a lot more computational and just brute force perspectives. This isn't just brute force. There's a ton of different techniques that are covered in Evans. All of the major introductions to some of the key techniques are covered in Evans. You're going to learn about weak solutions, weak form PDE, all these different representation formulas that you're going to need for PDE, and it's all done in Rn. It's all done in n dimensions, okay? Everything is done in Rn. All the PDE are done in Rn. Here, it's a bit more abstract, of course, but yeah, these are my recommendations, and then I have this other random textbook here that somebody gave this to me as a gift, so I can't recommend it. I don't know. I haven't read it. I don't know anything about it. Okay.